14 billion years ago, everything you see around you, every star, every planet, every grain of dust, was compressed into something smaller than an atom. Then, in a moment we call the Big Bang, it erupted outward faster than light itself, filling space with energy and matter that would one day form galaxies, suns, and eventually us. At least, that's the version of the story you've probably heard 1,000 times before. But what if we have it backwards? What if the Big Bang wasn't the beginning of everything, but instead the result of something far stranger? Imagine for a moment that our universe isn't a self-contained miracle, but the byproduct of an event in another cosmos. Imagine that instead of being born from nothing, our reality was hurled into existence through the eruption of a white hole, the explosive twin of a black hole, pouring out matter and energy from a hidden dimension beyond our comprehension. This idea flips everything we think we know on its head. The Big Bang has always been treated as a starting point, the ultimate origin story, but the problem with that explanation is simple and unavoidable. How can something come from absolutely nothing? The mathematics of physics work perfectly well up to a point, but the moment you rewind all the way back to that first instant, everything collapses into nonsense. Equations break, numbers hit infinity, concepts like time and density lose meaning. It's like trying to divide by zero on a calculator. The only thing that flashes back at us is error. For decades, this has been the great frustration of cosmologists. We can explain what happened 1 second after the Big Bang, even a trillionth of a second after, but the very moment itself, that remains impossible. And yet, here we are, living proof that it happened. This is where the white hole hypothesis begins to creep in. We already know that black holes exist, and they are just as baffling. They trap everything behind their event horizons and squeeze it down to an unfathomable singularity. But Einstein's theory of relativity doesn't just allow for black holes, it predicts their mirror opposites. Instead of pulling everything in, white holes would throw everything out. Instead of swallowing light, they would blaze brighter than anything we could imagine, spewing radiation, matter, and energy into space at unstoppable speeds. Doesn't that sound uncannily familiar? The birth of our universe looks exactly like what a white hole would do. And if that's true, then we need to ask the question that makes scientists uncomfortable. Where did all the matter of our Big Bang really come from? Because if our universe is the output of a white hole, then somewhere else, perhaps in another dimension, perhaps in a parent universe, a black hole was swallowing stars, planets, maybe even civilizations. Everything that fell in would have been funneled through the fabric of space-time and expelled on our side as the cosmic fireball we call the Big Bang, which means the atoms in your body, the iron in your blood, the oxygen in your lungs, could quite literally be recycled material from a universe that died long before ours ever began. This possibility turns our existence into something far more mysterious and unsettling. We may not be the first act of creation, we may not even be unique. Our universe might just be one link in an infinite chain of connected realities, each one feeding the next through black holes and white holes, recycling matter and energy in a cosmic system without beginning or end. Suddenly, the Big Bang doesn't look like a beginning at all. It looks like a continuation. And if that's true, then everything we thought we knew about our origin story may just be a fragment of something infinitely larger, stranger, and more profound. We stand at the edge of the greatest riddle science has ever faced. And it begins with a simple but devastating question. How can something come from nothing? The Big Bang is often presented as a clean, elegant theory. 13.8 billion years ago, all matter, all energy, and even time itself were compressed into an unimaginably small point, a singularity, and then suddenly burst outward, giving rise to everything we know. It's a story told in classrooms, documentaries, and science books, as though the mystery has been solved. But when physicists push their equations back to that first instant, Reality itself falls apart. Numbers spin out of control, values stretch toward infinity, and the rules that govern every atom in the universe refuse to play along. It's as though nature has drawn a thick black line at the moment of creation and written across it, "Do not enter." Think about what this means. We can calculate with astonishing precision what the universe looked like when it was 1 second old, 1 millisecond old, even 1 trillionth of a second old. We can model the density, the temperature, the formation of fundamental particles. But when we try to cross that final boundary to the exact beginning, our tools fail completely. Time itself ceases to have meaning. Density becomes infinite, temperature becomes infinite, and every elegant equation humanity has ever discovered simply breaks. It's like trying to divide by zero. No matter how you approach it, no matter how sophisticated your mathematics becomes, you run headfirst into error. For decades, this has haunted the brightest minds in cosmology. How do you explain a universe emerging out of nothing at all? Every attempt to solve it just pushes the question back one more step. Maybe time itself began at the Big Bang, meaning there was no before to even consider. Maybe our cosmos is just one bubble in an infinite foam of universes, each one expanding, colliding, or popping in an endless cosmic sea. Maybe everything we see was born from a quantum fluctuation, a ripple in a strange underlying field where particles pop in and out of existence. These explanations are clever, even beautiful, but they all share one fatal flaw. Each one requires something to exist first. Time, space, quantum fields, physical laws. None of them explain the leap from absolute nothingness to everything. This is where the discomfort sets in. Scientists pride themselves on unraveling mysteries, on replacing myths with testable facts. But the Big Bang presents a paradox too sharp to ignore. It asks us to believe that all of reality, the galaxies, the stars, the very atoms in your body, simply appeared from nowhere, without a cause, without a mechanism, without even a framework in which to occur. To say this is unsatisfying is an understatement. For many, it feels less like science and more like magic with an academic label. And yet the evidence of cosmic expansion is undeniable. The universe is stretching. Galaxies are moving away from each other. The afterglow of the Big Bang still bathes every corner of the sky in faint microwave radiation. Something happened. Something explosive. Something universe-making, but the story we tell about it may be incomplete, and the missing pieces could be more unsettling than we ever imagined. Some physicists have started to look at another phenomenon in the universe, one that carries eerie similarities to the Big Bang itself. Black holes. These cosmic monsters form when massive stars collapse under their own weight, squeezing matter into such incredible density that not even light can escape their grip. At their core lies another singularity, another point of infinite density where our equations fail, where time and space lose meaning. In other words, the birth of the universe and the death throes of stars seem to share the same fingerprints. The Big Bang looks less like a unique creation event and more like a cousin of something we already see happening across the cosmos. The question is, if black holes swallow matter into singularities, is there an opposite process? Could there be something out there that does the reverse, not pulling everything inward, but throwing it outward? If black holes represent the ultimate trap, swallowing everything into a point of no return, then what about their mirror image? Einstein's equations don't just describe black holes, they also allow for their opposite, a white hole. Where a black hole consumes, a white hole expels. Where nothing can escape from a black hole, nothing can enter a white hole. Imagine approaching one of these cosmic fountains. Instead of darkness and silence, you'd be met with a blaze of energy brighter than anything in the known universe. Matter streaming outward at impossible speeds. radiation pouring into space in every direction. It would be the polar opposite of collapse, the very definition of eruption. The comparison to the Big Bang is unavoidable. Think about it. Both begin with a singularity, a point of infinite density where physics as we know it collapses. Both involve staggering amounts of energy and matter appearing at once. Both are surrounded by a kind of horizon that separates inside from outside, past from future, possible from impossible. A black hole's event horizon traps you forever, while a white hole's horizon locks you out completely. And what does the Big Bang look like? An event horizon that expands outward, scattering matter everywhere. The resemblance isn't just poetic, it's mathematical. The same equations that describe black holes also contain the seeds of white holes. For decades, they've existed as a kind of theoretical ghost, predicted by relativity but never observed. Yet the more we examine the early universe, the more the idea refuses to stay in the shadows. What makes white holes even stranger is the way they seem to break time itself. At the edge of a black hole, time slows almost to a crawl for an outside observer. At the edge of a white hole, relativity predicts the opposite. Time flows backward. If you could watch a white hole erupting, the sequence of events would appear reversed. The last particles to leave its core would be the first ones you saw, while the earliest bursts of matter would appear last. It's a kind of temporal trickery that makes even black holes seem straightforward by comparison. And it raises a disturbing possibility. Perhaps white holes can only exist under very specific conditions. Conditions that may have only occurred once, at the very birth of our universe. Now ask yourself, if our Big Bang really was a white hole, where did all that matter and energy come from? White holes don't create material out of nothing. They eject it, which means everything around us, the stars overhead, the ground beneath our feet, the molecules that form our blood and bones, may not have originated here at all. It may have been funneled from somewhere else. From the heart of a collapsing star in another cosmos, from the swirling accretion disks of black holes devouring their galaxies in a parent universe, from worlds, maybe even civilizations that vanished behind an event horizon, only to be reborn on our side as the ingredients of a new reality. This idea is both exhilarating and unsettling. On the one hand, it offers a way out of the dead end of something from nothing. On the other, it suggests our universe is not unique, not original, but a kind of cosmic aftershock, the exhaust plume of a far older realm. If true, it means the Big Bang was not the beginning, but a continuation, a handoff in an eternal relay race, where black holes feed white holes, which birth new universes in an infinite chain. And if that's the case, then our story is not about creation from void. It's about inheritance, which forces us to ask the next question: what exactly is on the other side of the cosmic mirror? White holes sound like something ripped from science fiction, yet they fall naturally out of the mathematics of Einstein's general relativity. The same equations that predict the crushing prisons of black holes also describe their impossible opposites. Picture space-time as a rubber sheet. A black hole is like pressing your finger into that sheet until you create a pit so deep that nothing can climb back out. A white hole is the reverse, an impossible mountain rising upward, ejecting everything that tries to touch it. Where black holes hide in shadows, white holes would shine like cosmic lanterns, blazing with a brilliance we can scarcely imagine. They would be the brightest objects in existence, not because of nuclear fusion like stars, but because of matter and energy exploding outward in torrents that never end. If you stood near the edge of a black hole, you could in theory cross the event horizon and fall inward, though you'd never escape. With a white hole, the event horizon becomes a barrier you cannot breach. It's like standing in front of a waterfall, flowing upward at infinite speed. No matter how hard you try, you'll never swim against the current. From outside, the white hole would look like a sphere of pure fire, with matter and radiation blasting away at the speed of light. The particles that pour out would emerge already moving faster than light itself inside their warped geometry, only slowing down as they crossed into the normal space-time we experience. This strange behavior makes white holes even more baffling than their black hole cousins. Relativity tells us that time bends and warps around massive objects. At the edge of a black hole, time seems to stop entirely for anyone watching from outside. But at the edge of a white hole, the arrow of time appears to reverse. Matter would leave in an inverted sequence, the last particles coming out first, the first particles emerging last, like watching a film played backward. No wonder scientists have trouble imagining them existing in our present-day universe. The conditions required might have only existed at the very beginning, when reality itself was unstable and raw. That's why some theorists suspect the Big Bang was not only the birth of our universe, but the only true white hole we will ever encounter. But if white holes can't create something out of nothing, then they demand a source. And here is where things become truly unsettling. A white hole is not independent. It doesn't generate its own material. It must be connected to something else that is feeding it. If the Big Bang was a white hole, then our universe is connected to a black hole somewhere beyond our reach, in another universe, another dimension, perhaps a reality whose laws of physics echo our own. In this view, black holes and white holes are not isolated freaks of geometry, but two ends of the same tunnel. One swallows, the other spits. One is an entrance, the other an exit. Together they form a wormhole, a bridge through space-time known as an Einstein-Rosen bridge. That means when a star collapses in one universe, forming a black hole, the story may not end there. On the other side of that collapse, somewhere we cannot see, a new cosmos might ignite in a titanic eruption. The matter consumed in one realm becomes the foundation of another. Each black hole would then be a potential cradle for a new universe, while each white hole would be the birth cry of one already in progress. The thought is staggering. Our Big Bang might not have been a beginning at all, but a continuation of this endless cycle, the outflow of a parent black hole from a reality we will never observe, which forces us to wonder, if this is true, then how much of what we see around us, our galaxies, our stars, even ourselves, was born not from void, but from the ruins of another universe's death throes? If black holes are not the ultimate graves of matter, but the openings to something new, then the universe is far stranger than anyone ever imagined. For most of modern science, black holes have been painted as final destinations. A massive star collapses, its core crushed by gravity until nothing can withstand the pressure, and all that remains is a region of space-time from which no light can ever escape. To an outside observer, whatever falls in seems to vanish forever, lost beyond an invisible horizon. But relativity hints at another possibility. The interior of a black hole and the interior of a white hole can be described by the same equations, two sides of the same geometry separated only by the direction of time. If that's the case, then every black hole might be a doorway, a tunnel through space-time itself, ending in a white hole that erupts in some other place, maybe some other universe. This connection is known as an Einstein-Rosen bridge, though most people call it by another name, a wormhole. It's a solution baked into the mathematics of relativity, though so exotic and unstable that many physicists once dismissed it as nothing more than a curiosity. Yet if the Big Bang truly was a white hole, then wormholes are not curiosities at all. They may be the hidden framework of reality, the plumbing of the multiverse. Picture it. Every time a black hole forms in our universe, everything that falls inside, planets, stars, dust, even the light itself, might not be annihilated. Instead, it could be funneled down a corridor of warped space-time and expelled into another realm entirely. To us, it looks like destruction. To them, it would look like creation. If this is true, then our own universe may be the child of another. Somewhere, perhaps in a cosmos with laws of physics almost identical to ours, a colossal black hole collapsed and poured its contents through an Einstein-Rosen bridge. On our end, it appeared as the Big Bang, the singular eruption that gave rise to everything we know, which means that black holes in our universe may be doing the same thing right now. As stars reach the end of their lives and implode into these dense objects, they could be sowing the seeds of new universes, each one invisible to us, but blazing into existence elsewhere. Every black hole might be a cosmic womb, while every white hole might be a cosmic birth. Creation and destruction would not be opposites, but two halves of the same process. The implications are staggering. If every black hole leads to a white hole, then the death of matter here is the birth of matter there. Universes could be chained together endlessly, each one feeding the next, recycling energy and information across unimaginable gulfs. Our own cosmos could be littered with gateways, silent and dark on the outside, but on the other side exploding with unimaginable fury. What looks to us like an abyss may be, for another universe, the very first dawn. This view also reframes the Big Bang itself. Instead of demanding that everything sprang out of nothing, it suggests our universe was seeded with material from a parent cosmos. The singularity at the heart of that parent black hole became our singularity, and when it erupted, it did so not into emptiness, but into a brand new space-time of its own. From the outside, a black hole looks like a tombstone. From the inside, it might look like Genesis, and if that's the case, then we are not the product of spontaneous creation. We are the descendants of another universe's death. Everything around us could be recycled, the galaxies above, the atoms that build our bodies, even the time and space we inhabit. All of it may have been born on the other side of an event horizon we will never see. If our universe really is the outflow of a white hole, then somewhere in the fabric of the cosmos, we should see fingerprints of this hidden origin. Scientists have been staring at the sky for decades, mapping the leftover glow from the Big Bang, measuring the motion of galaxies, searching for subtle patterns that can't be explained by the standard story. And the more carefully they look, the more the evidence seems to whisper that something doesn't quite add up. Take the cosmic microwave background, for example, the faint afterglow of radiation that fills the entire universe. It's the most ancient light we can observe, dating back almost 14 billion years, a snapshot of the cosmos when it was only 380,000 years old. To most people, it just looks like random static, but to cosmologists, it's a treasure map, a blueprint of our origins. The problem is that it's almost too perfect. Regions of space, separated by billions of light years, share nearly the exact same temperature as though they coordinated with each other. But according to standard Big Bang theory, they never had the chance to communicate. Light simply hasn't had enough time to travel between those distant regions. It's called the horizon problem. And inflation theory, an idea that space itself ballooned faster than light in the earliest moments, is usually offered as the solution. But inflation requires fine-tuned physics and exotic mechanisms that we've never seen in nature. The white hole hypothesis provides a simpler answer. If everything in our universe came pouring from a single singularity, a single outflow, then of course it began with uniform conditions. The temperature was set at the source, the signature of whatever collapsed into the parent black hole, and that uniformity spread outward naturally. But the microwave background doesn't just show uniformity, it contains strange anomalies, scars in the fabric of the sky that defy explanation. There are cold spots too large to be random chance. There are alignments of radiation patterns that seem to point in specific directions, as if the universe has a preferred axis. Standard cosmology struggles with these. But a white hole origin could explain them. If the parent black hole was spinning, if it was distorted by nearby objects, if magnetic fields shaped its collapse, then those asymmetries would be imprinted on the material erupting from the white hole. The universe would carry the fingerprint of its parent's geometry written across the sky in subtle temperature fluctuations that we can still detect today. Even more disturbing are the colossal structures we've discovered on cosmic scales. The Great Attractor, for instance, a mysterious region pulling our galaxy and thousands of others toward it at staggering speeds. Or the Great Wall, a sheet of galaxies stretching more than 500 million light-years across, so vast that light hasn't had enough time since the Big Bang to cross its length. Yet somehow it holds together. According to the Standard Model, such structures should never have formed, not in the time our universe has existed. But if the matter in our cosmos erupted from a white hole, it wouldn't have been evenly scattered. It would have emerged with flows and currents determined by the shape and spin of the parent black hole. The Great Attractor and the Great Wall might not be coincidences. They might be fossilized remnants of those initial flows, evidence of directionality baked into the universe from its very first moment. When astronomers map the motion of galaxies, they find something else unsettling. On the largest scales, clusters of galaxies appear to be moving together as though being dragged in the same direction by an invisible force. This so-called dark flow stretches across billions of light-years, and no one can explain it with standard cosmology. But if our universe is still carrying the momentum of matter expelled from a white hole, then that dark flow is exactly what we should expect. The eruption wasn't perfectly even. It blasted more material along certain axes, and billions of years later, those are still visible in the cosmic traffic patterns of galaxies. It's as if the universe is still remembering the violence of its birth, still echoing the orientation of the black hole that created it. Taken individually, these puzzles might be brushed aside as coincidences or anomalies. But together they form a picture that is difficult to ignore. The cosmic microwave background's eerie uniformity, its unexplained cold spots and alignments, the impossible size of galactic structures, the mysterious flows that tug entire clusters across the sky. All of them point to a universe whose birth was not a simple explosion from nothing, but the outflow of something else, somewhere else. And if that's true, then the sky above us isn't just a window into the past. It's a message from another universe, encoded in radiation and motion, daring us to decipher it. For nearly a century, astronomers have been haunted by a ghost. They can see its influence everywhere, yet they cannot touch it, cannot trap it, cannot even describe it with confidence. It's called dark matter, and it makes up about 85% of all matter in the universe. Without it, galaxies would fly apart, stars would scatter like sparks from a fire, and cosmic structure would never have formed the way we see it today. Yet despite decades of searching, every laboratory on Earth has come up empty. No detector has captured a dark matter particle, no accelerator has produced it, no telescope has identified its glow. The silence is deafening. The deeper the search goes, the stranger the mystery becomes, and perhaps the reason we cannot find dark matter is because we're looking in the wrong place. Perhaps it isn't here at all. The idea is unsettling, but it fits disturbingly well with the white hole hypothesis. If our universe was born from the outflow of a white hole, then it is still connected, in some hidden way, to the black hole that created it. And black holes don't just swallow matter, they drag space-time itself with them. The gravitational fields surrounding them are immense, stretching beyond their horizons. What if some of that gravitational influence leaks through the Einstein-Rosen bridge into our reality? In other words, what if dark matter is not some exotic new particle, but the shadow of matter in another universe, its gravity bleeding across dimensions? Think about what that would mean. Every galaxy we see is wrapped in a vast halo of invisible mass, shaping its rotation, holding it together. Astronomers can measure the way stars move and map out these halos in detail. And the shapes match what you'd expect if galaxies in another universe, clusters of stars and planets orbiting their own black holes, were tugging on us through a wormhole connection. We are not being held together by something new, but by something familiar, just displaced. The hidden scaffolding of our cosmos could be the ordinary matter of another reality, invisible to us but pressing its weight into ours. Even the ratios seem to match. There is about 5 times more dark matter than ordinary matter in our universe, an odd balance that has always puzzled cosmologists. But if only a fraction of the material falling into black holes makes it through to the other side, then inefficiency alone could explain that ratio. The rest of the matter would remain locked in the parent universe, while only a portion emerges here as the atoms and particles we recognize. The leftovers, their gravitational pull still stretching across the bridge, would manifest as dark matter in our reality. That would also explain why dark matter interacts only through gravity and nothing else. It isn't here to collide with, it exists elsewhere, its pull reaching across the dimensional divide like the shadow of a hand pressed against a wall. This view even explains some of the strangest behaviors dark matter exhibits. During galaxy collisions, for example, astronomers have watched the stars and gas slam into each other, heating up and scattering, while the dark matter halos pass through one another almost untouched. In our universe, this looks bizarre, but if dark matter is simply the gravitational echo of mass in another universe, it makes perfect sense. The shadows don't interact with each other because the actual objects casting them exist in separate realities. To us, they seem ghostly and aloof, but in their own cosmos, they may be perfectly ordinary galaxies, burning with suns and perhaps even home to civilizations we will never know. If this is correct, then the reason we can't find dark matter particles is brutally simple. They don't exist here. We are feeling the weight of another universe pressing into ours, invisible yet undeniable, and that raises a haunting possibility. If the scaffolding of our cosmos is shaped by the mass of another, then our structure and their structure are tied together. We may be living in a cosmic mirror, our galaxies forming in lockstep with galaxies in another realm, connected by the hidden threads of gravity stretching through wormholes. To us, the mystery is dark matter. To them, we might be the shadow. If dark matter is the gravitational echo of another universe, then perhaps gravity is not the only thing that leaks across. Physics has long hinted at connections between worlds that defy distance, the strangest of which is quantum entanglement. Two particles can be created together in such a way that their properties are linked. Measure one and the other instantly responds, no matter how far apart they are. Einstein himself called it spooky action at a distance, because it seemed to violate the most fundamental law of relativity, that nothing can move faster than light. But what if these particles aren't whispering across space at all? What if their connection is routed through the same wormhole geometry that links black holes to white holes? Instead of sending signals across the universe, they would be using shortcuts through hidden dimensions, channels outside the limits of normal space and time. This possibility gains even more weight when we consider how our universe might be structured at the most fundamental level. Some of the brightest minds in physics now believe that reality itself may be holographic. That's not to say it isn't real, but that the three-dimensional world we experience could be the projection of information encoded on a distant two-dimensional surface. This idea comes from the study of black holes, where theorists discovered that the amount of information a black hole can hold is proportional not to its volume, but to the surface area of its event horizon. Imagine that everything that falls in, every particle, every detail, gets smeared across the boundary like data etched on a cosmic hard drive. From the outside, an object collapsing into a black hole would appear frozen on the horizon, its information spread out in a thin, glowing skin. From the inside, it continues to fall toward the singularity. Two perspectives, both valid, both describing the same reality. If our Big Bang was actually a white hole, then everything we see, every galaxy, every planet, even our own consciousness, might be a projection from information stored on the surface of the parent black hole. The universe we inhabit could be nothing more than the three-dimensional shadow of two-dimensional data encoded somewhere else. Even stranger, entangled particles in our world may appear connected because they are both reflections of the same underlying record. When we measure one, we are really accessing information stored on that hidden surface, which simultaneously defines the other. What seems like instantaneous communication is simply the consistency of a hologram. This interpretation doesn't just apply to particles, it may apply to us. If all the atoms in our bodies are part of this holographic projection, then our thoughts, our memories, our very awareness may be encoded information carried forward from the parent black hole and projected into this new reality. Consciousness might not have arisen here at all. It might be a continuation of information that already existed elsewhere, translated into the patterns of a new cosmos. That means the mysterious sense we have of being more than just flesh and blood, of being part of something bigger, might not be illusion, it might be the literal truth of our existence. And if this holographic principle is correct, then death itself may not be what we think. When information falls into a black hole, it is not destroyed. It remains stored, etched into the event horizon, which suggests that the information that makes us who we are, the patterns of neurons, the flow of thought, cannot be erased either. Even as universes die and collapse, the data survives, waiting to be projected again in another form. Consciousness could be fundamental and indestructible, migrating across realities just as matter and energy do. In this light, entanglement becomes not just a physics experiment, but a hint that our universe is tied to others in ways far deeper than we can imagine. Every flicker of quantum behavior may be a message from across the divide, a reminder that what we see is not all that exists. If our universe is the outflow of a white hole, then the matter that makes up everything we know did not originate here. It was transported, funneled through a cosmic tunnel, torn from another place and another time. That realization alone is staggering, but it carries with it an even more haunting implication. The atoms in your body, the carbon in your DNA, the iron in your blood, may once have belonged to something else entirely, perhaps even to beings who lived, thought and dreamed in a universe that existed long before ours was born. In that parent reality, massive stars burned, planets orbited, and maybe civilizations rose, building their histories under skies that will never be seen by us. When one of their suns collapsed into a black hole, everything they knew was drawn into its event horizon, compressed toward the singularity. To them, it may have looked like annihilation. To us, it looked like creation. The matter they lost was the matter we gained, hurled outward in the eruption of our Big Bang. Imagine this possibility more concretely. Somewhere in a cosmos with laws of physics not so different from our own, an advanced civilization might have existed. They watched their star grow unstable, its light growing erratic, the warning signs of a giant's death. They might have known what was coming. Perhaps they tried to escape, sending ships across the void, searching for safety. But gravity is merciless. As their world fell toward the black hole's horizon, they would have experienced time differently. To an outside observer, they froze in place, caught forever in the final moment. But to themselves, time flowed on, as usual. Their skies warped, their planets stretched and shattered by tidal forces, their very existence pulled toward a singular end. They would have felt their world falling apart, the last moments of their history disappearing into an abyss they could not resist. And yet, if the white hole hypothesis is true, their end was not truly the end. The quantum information of every particle that made up their bodies, their cities, even their thoughts, would not have been erased. It would have been carried through the Einstein-Rosen bridge, encoded in the singularity, and expelled into our universe. The carbon atoms that once carried their genetic codes may now be the carbon that shapes our DNA. The oxygen molecules they once breathed may now cycle through our atmosphere. The iron that flowed in their blood may pulse in ours. We are not only the children of stardust, we may be the descendants of forgotten civilizations, living echoes of lives that ended billions of years ago. This perspective transforms how we see the night sky. The galaxies above us may not just be distant, they may be memorials. Their patterns, their distributions, even the radiation that hums quietly across the cosmos, could be shaped by the collapse of worlds in a parent universe. What we call cosmic background radiation may contain subtle imprints of temperatures that once belonged to planets orbiting foreign stars. The structures we see in galactic flows might reflect the geometry of star systems that once thrived before falling into the abyss. In this sense, our universe is not a blank slate, but a palimpsest, written over with the faint but indelible record of what came before. To live in such a universe is both humbling and empowering. We are not isolated, not the first, not unique. We are the continuation of something older, carrying forward material, energy, and perhaps even fragments of memory across the boundaries of universes. Every breath we take is shared with ghosts we will never meet. Every step we walk is grounded on atoms that once formed the landscapes of another cosmos. We are their resurrection, their afterlife, their impossible second chance. And just as we inherited their legacy, our own universe will one day collapse, feeding the birth of another. Somewhere, sometime, new beings may walk under new skies, built from the remnants of us, never knowing they carry within them the echoes of a civilization that once pondered its own mysterious origins. If our universe was born from the outflow of a white hole, then its eventual fate is tied to the very process that created it. Just as every star dies, so too does every black hole, and if every black hole is linked to a white hole in another universe, then death ripples outward across the multiverse like falling dominoes. For a long time, black holes were thought to be eternal prisons, places where matter and information vanish forever. But Stephen Hawking revealed that this isn't true. Black holes leak energy, emitting faint radiation that slowly drains their mass. Over unimaginable stretches of time, they evaporate completely, dissolving into nothing but heat. The larger the black hole, the longer it takes. Stellar mass black holes will last longer than the current age of the universe, while supermassive black holes at galactic centers might survive for trillions upon trillions of years. Yet even they are not immortal. One day every black hole in our cosmos will fade away. Now consider the consequences of this in a multiverse linked by wormholes. If a white hole depends on its parent black hole, then when the parent dies, the white hole collapses too. If our Big Bang was the outflow of a black hole in another universe, then our entire reality rests on the lifespan of that parent object. Should it evaporate, the bridge connecting our cosmos to its source would shut off, like a faucet running dry. The flow of energy that fuels our cosmic expansion would cease, and in time our universe could reverse its course, collapsing back into singularity. That means the life of one universe may depend entirely on the health of another. We are not isolated, we are tethered. This interdependence paints a picture of the multiverse as a vast ecosystem, where universes feed each other, recycle each other, and die together. A massive star in one universe collapses, forming a black hole that ignites the birth of a child cosmos through its white hole twin. That new universe flourishes, expands and forms its own stars, which in turn collapse into more black holes, spawning further universes down the line. Each universe nourishes the next, like links in an infinite food chain. Matter and energy are never truly lost, only passed along, transformed, and reborn. Death in one realm becomes life in another. But ecosystems can collapse. In nature, if one link in the chain breaks, the consequences ripple outward, starving everything else connected to it. The same may be true of the multiverse. If a parent universe reaches heat death, if its stars burn out and its black holes evaporate, it may stop producing new offspring. The flow of matter and energy would slow, then cease, leaving its children vulnerable. Those child universes, including ours, might begin to wither as the bridges sustaining them collapse. A cascade of extinction could follow, whole chains of universes dying as their links snap one by one. What seems eternal may be far more fragile than we dare to believe. And yet, within this grim scenario, there lies a strange hope. Just as life in a biological ecosystem adapts and evolves, universes may do the same. Those that generate many massive stars create many black holes, spawning more child universes and spreading their lineage wider. Universes poor in star formation may leave few descendants and fade away. Over time, the multiverse could evolve toward conditions that maximize survival, producing configurations of physics that favor complexity, structure, and perhaps even consciousness. If so, then we live in a cosmos shaped not only by physics, but by a kind of natural selection on the grandest scale imaginable. Our universe exists as it does because others before it failed, and because those that succeeded left behind offspring strong enough to survive. In this vision, we are not just random accidents drifting in an indifferent void. We are part of a living web of realities, a cosmic forest where each universe feeds the next. Our fate is tied to the death of others, and our death will one day nourish another's birth. The multiverse becomes not an abstraction, but an ecosystem, fragile and beautiful, sustained by cycles of destruction and creation. And just as with every ecosystem, the question lingers: how long before collapse comes for us, and what kind of universe will rise from our ashes? If every universe is born from the collapse of another, then we are faced with a question that is as simple as it is impossible: where did it all begin? If our Big Bang was the outflow of a white hole, and that white hole was linked to a black hole in a parent universe, then what gave rise to that parent? Did it also emerge from a white hole in yet another reality? And if so, where did that one come from? The chain stretches backward without end, each universe giving birth to the next, each collapse fueling another explosion. But this creates a problem that philosophers and physicists have wrestled with for centuries: infinite regression. If there is always another universe before ours, then we never reach a true beginning. We are stuck in a loop of causes without a first cause, a story without a first chapter. This is deeply unsettling because our minds crave an origin. In everyday life, every effect has a cause. Every action has something that came before it. A tree grows because a seed was planted. A seed exists because a tree produced it. But in this chain, we can eventually point to the first tree. In the multiverse, that point may never exist. Reality may be an endless cycle, a wheel turning without ever starting or stopping, universes feeding universes in an eternal loop. To some, this seems unsatisfying, as though the ultimate answer is only to push the question further back forever. But perhaps that is the nature of existence itself. Perhaps there was never a beginning, only an infinite series of transformations, each one birthing the next in an endless dance. Some physicists believe there could be a way out of this regression. One possibility is that the chain loops back on itself. In this scenario, the multiverse forms a closed causal structure where Universe A gives rise to Universe B, Universe B gives rise to Universe C, and Universe C eventually gives rise to Universe A again. If this is true, then the multiverse is self-contained, needing no external cause, no first universe. Each one is both parent and child, caught in a perfect circle of creation. Another possibility is that the infinite sequence of universes converges on a stable pattern, the way an infinite series of numbers can converge to a finite value. In this view, reality is shaped not by a first cause but by the mathematical balance of infinity itself. But there is an even more disturbing possibility, that reality has no ultimate explanation at all, that it does not require a beginning, a foundation, or a deeper reason. It simply is. Existence may be self-sustaining, a chain of universes that requires no origin, no starting point, no guiding principle. For human minds built on cause and effect, this is almost unbearable. We want to know why, but the universe may not have a why. It may only have an endless series of whats, each one springing from the last, with no final answer waiting at the end of the line. And yet, within this infinite regression, there might still be patterns that give meaning. If universes evolve, if they inherit structures, constants, and information from their parents, then the multiverse is not just random chaos. It is an endless genealogy, a family tree without a trunk, where branches extend forever, but still shape each other. Our universe may be the child of countless others, and the ancestor of countless more. The laws of physics we live under may not be arbitrary. They may be the accumulated legacy of generations of universes, fine-tuned by survival, honed by the demands of creating stars, galaxies, and life. So the paradox remains: did the multiverse have a beginning, or has it always existed? Perhaps the question itself is flawed, a symptom of our limited perspective. For beings trapped inside time, beginnings and endings seem essential. But for the multiverse, time itself may be just another layer of the illusion, a projection like everything else. From a higher perspective, perhaps there was never a first moment. There has only ever been existence, reshaping itself endlessly, recycling matter, energy, and even consciousness across an infinite chain. And if that is true, then the real mystery is not how it all started, but why there is something at all instead of nothing, and whether that question even has an answer we could ever hope to understand. If the multiverse is truly an endless chain of universes, then the obvious question becomes, what role, if any, do we play in this incomprehensible system? For most of history, humans have seen themselves as small, fragile, and temporary, adrift in a vast cosmos that is indifferent to our existence. Yet, if our universe is one link in a living web of realities, then perhaps intelligence itself is not an accident, but a vital feature. Consider this: we are the first generation of beings, at least in our recorded history, capable of looking back at the Big Bang and asking whether it was a white hole. No other species on Earth has ever wondered about the birth of the universe. No star, no planet, no black hole has ever questioned its own origins. But we do, and by doing so we may be serving a purpose larger than survival, larger than evolution. We may be the universe becoming aware of itself. The implications are staggering. If every black hole spawns new universes, then eventually advanced civilizations might learn how to influence what falls into them. What if a sufficiently advanced species could control the matter, energy, and information collapsing into a black hole, effectively programming the conditions for the white hole on the other side? This would mean that universes are not just born randomly, but can be cultivated, engineered, or even designed. Our universe might not be purely an accident of physics. It might be the result of choices made in a parent cosmos by beings we will never meet. And now we stand on the threshold of reaching that same level of influence. With our growing ability to manipulate matter at the quantum level, with particle accelerators capable of recreating early universe conditions, with telescopes that peer to the edge of time itself, we are developing the tools to shape reality on a scale that was once unthinkable. This brings with it a burden unlike any other. If our experiments can create conditions that mimic black holes, then every decision we make might ripple into realities beyond our own. When we collide particles at unimaginable energies, could we be seeding child universes without realizing it? If so, then we are not simply explorers, we are creators. And if we are creators, we are also responsible. What moral obligations do we have to the civilizations that might arise in the universes we inadvertently generate? Should we try to minimize suffering? Should we maximize diversity, intelligence, or stability? These are questions humanity has never been forced to ask, but they may soon become unavoidable. And even beyond creation, our role as observers carries weight. Every discovery we make expands the universe's awareness of itself. When we decode the laws of physics, we are not merely learning, they are being revealed from within. The equations were always there, woven into the structure of existence, but it takes conscious beings to notice them, to speak them aloud, to share them across generations. In this sense, our curiosity is not trivial. It is essential. Through us, the multiverse develops knowledge, memory, and maybe even direction. Without conscious observers, reality would unfold silently, blind to its own beauty. With us, it gains eyes to see itself, minds to question itself, and voices to wonder whether there is more beyond the veil. So perhaps our role is twofold: to understand and to shape, to uncover the truth of where we came from, and to make choices about where future universes may go. We may be inheritors of a legacy stretching back through countless realities, and at the same time, the architects of realities yet unborn. It is a terrifying responsibility, but also a profound honor. We are not just passengers in the cosmic cycle, we are participants, and what we choose to do with our knowledge, with our technology, and with our imagination may determine the fate of universes that will never even know our name. We began with the question, was the Big Bang truly the beginning? Or was it the eruption of something far stranger, the outflow of a white hole spilling matter from another universe? Along the way, we have followed the evidence through singularities, wormholes, and cosmic echoes that seem to suggest our reality is not a self-contained miracle, but part of a vast interconnected network. Each black hole in our universe may be a womb for another cosmos. Each white hole may be the first cry of existence in a new dimension. Matter flows endlessly between them, recycled across ages, restructured, reborn. In this vision, nothing is wasted. Nothing is lost. Stars die, galaxies collapse, and even entire universes fall into the abyss, only to rise again as the birth cry of something new. It is a story of death and rebirth, written on a scale that dwarfs human imagination. And yet somehow we are here, conscious observers capable of asking what it means. If this picture is true, then our universe is not unique. It is not the first, nor will it be the last. It is one of countless realities linked together, feeding each other like nodes in a living web. The atoms in our bodies may have once belonged to civilizations that vanished behind the horizon of a parent black hole. Our own black holes may be sowing the seeds of future universes right now, places where new beings will one day look up at alien skies and wonder about their origins, never knowing they are the children of our collapse. In this way, every action, every choice, every discovery echoes far beyond our own lifetime, beyond our own world, beyond even our own universe. We are part of a continuum, bound into a cycle of creation and destruction that stretches infinitely in both directions. And yet, the most profound revelation may not be about the multiverse at all, but about ourselves. If the holographic principle is correct, then we are not merely matter arranged into temporary forms. We are information, encoded, preserved, and projected across realities. Consciousness may not have arisen here by accident, but could be the inheritance of previous universes, carried forward through the collapse of stars and the rebirth of worlds. That means we are not just observers of the cosmos. We are its memory. We are its awareness. When we study the universe, when we discover its laws, when we imagine its possibilities, the universe is doing that to itself through us. Our curiosity, our hunger to know, is not separate from reality but intrinsic to it. We are the eyes of the multiverse, looking back at itself. This understanding brings both comfort and unease. Comfort, because it means nothing is truly lost. Death is not the end, but a transformation, the recycling of matter and information into forms we cannot yet imagine. The end of our universe will not erase us, but will seed the beginnings of others, but unease, because it places responsibility in our hands. If advanced civilizations can shape the conditions of new universes, then what we do here may ripple outward forever. The experiments we run, the technologies we build, the choices we make with the power of knowledge, may determine the fate of realities we will never see. That is a responsibility unlike any other, and it falls on us precisely because we are conscious, precisely because we can ask these questions. So, where does that leave us? Perhaps at the most extraordinary threshold in cosmic history. For billions of years, matter has blindly followed the laws of physics, collapsing into stars, burning, exploding, and collapsing again. But now, within us, matter has achieved something new. It has become aware of itself. It has begun to understand, and with understanding comes the possibility of direction. The multiverse may be eternal, infinite, and unyielding, but through us it has gained something it never had before, the ability to choose. Whether we use that gift to illuminate, to create, to preserve, or to destroy, only time will tell. But one thing is certain, the Big Bang was not the beginning. It was a continuation, and now, through us, the story continues still. When we look back at the story of the universe, it's tempting to imagine that we have reached some kind of final understanding. The Big Bang has been framed as the ultimate answer, the clean origin point from which all else has unfolded. But the deeper we peer into the equations, the stranger the universe becomes. What seemed like a beginning now looks suspiciously like a continuation. What we called creation may instead be inheritance. Our universe may be nothing more than the outflow of another, a white hole eruption connected to a black hole in a parent cosmos we will never see. If that is true, then every galaxy, every star, and every atom is a recycled fragment of realities that died long before ours was born. The iron in your blood could once have flowed in the veins of someone in another universe, their existence erased on one side of an event horizon and reborn here in you. This vision strips away the illusion of isolation. We are not alone in some self-contained bubble of existence. We are part of an infinite chain of creation and destruction, each universe feeding the next, each collapse seeding a new beginning. In this endless cycle, nothing is wasted, nothing is lost. Matter flows, energy transforms, and even consciousness may endure, carried as information through the bridges that bind realities together. We are both the product of other universes and the progenitors of universes yet to come. And when our own cosmos reaches its end, it will not be annihilation but transformation, the raw material for another reality that will rise from our ashes. Yet this perspective carries a weight. that is difficult to bear. For the first time in history, we are a species capable of recognizing the cycle and asking what it means. We are the universe looking back on itself, aware not only of its past, but of its potential. That awareness is not trivial, it is pivotal. If civilizations can influence what falls into black holes, then they can shape the birth of new universes, which means the choices we make today, the experiments we run, the technologies we create, may ripple across dimensions. We may already be creators without realizing it, seeding realities that will outlast our own. And if that is true, then we are faced with questions of responsibility unlike any faced before. Should we minimize suffering in the universes we create? Should we optimize for survival, for complexity, for intelligence? Or is our role simply to pass the torch, to let the cycle continue as it always has? What is certain is that the cosmos is far stranger and more interconnected than we once believed. The Big Bang is not an isolated miracle, but one eruption in an eternal network of eruptions. The multiverse may not have a beginning or an end, but instead may be a self-sustaining system, recycling matter, energy and information endlessly. And within that system, consciousness is not an accident. It is the mechanism by which the universe knows itself. Every thought we have, every equation we write, every question we ask is part of the cosmos awakening to its own nature. Our curiosity is not separate from reality. It is reality, expressing itself through us. So the next time you look at the stars, remember this. You are not just looking at distant suns. You are looking at a memorial to universes that came before and a promise of universes yet to come. You are the continuation of a story that has no first chapter and no final page. The atoms in your body have crossed horizons, survived deaths of stars, endured the collapse of worlds, and emerged here to live, breathe, and wonder. The universe has made itself conscious through you, and now it waits to see what you will do with that gift. For if the white hole hypothesis is true, then nothing is ever truly lost, and everything is forever becoming something more. And in that endless becoming lies the most extraordinary truth of all. We are not the end of the story, nor even the beginning. We are the story itself, unfolding across realities without limit, without origin, without end.